Good morning, ladies and gentlemen of Algebra 2 Honors. I'd like to give a special thanks to Lexi, who reminded me to plug in the microphone.
Thank you.
So sound today, courtesy of Lexi. Thank you, Lexi. All right, so now we're to where we left off yesterday, and we're going to use what we talked about yesterday to work out these things here. Identify the axis symmetry, then give the function's maximum or minimum value, domain, range, intervals where the functions increase or decreasing. So I don't know if you want me to help you through this, or if you just want to tell me. Why don't you tell me if you can? What is, for this problem 5, what is our axis symmetry? I'll call it AOS, or axis symmetry. What is our axis symmetry for this one? How does an axis symmetry formula start out?
1.
Let's talk about an axis symmetry. Okay, here we have this. Here's a parabola, right? Here's our axis symmetry.
Yeah. On vertex.
Well, the vertex is related to the axis symmetry, right?
Yeah.
So we have, like, the axis symmetry is the formula x equals h.
Yeah.
The vertex is the coordinate pair h comma k. So what is our axis symmetry for this particular situation here?
0.8. Right?
Okay.
1.6.
0.6.
No, it is not. No, you know.
Wait, what?
No.
Whatever you want.
You are missing some obvious
0.8 squared.
material here.
What's that? 0.8 squared. 1.6?
Lost.
0? What is it?
I'm so confused.
What is it? 0?
Okay, look, guys. You see can you read this for me here? What does it say?
X equals H.
Then, so what is our axis symmetry?
H.
X equals
H. 0.8.
0.8. I was waiting for somebody to say x equals.
Oh.
Okay?
Alright.
Yes, axis symmetry is an equation. An equation, right? X equals 0.8 in this case. Then give the function's maximum value. So maximum, what is our maximum for this? Our maximum value.
0?
Okay. Marcus says 0. Is that right?
No.
Hold on. What you...
Maybe.
Marcus is right. Why is Marcus right?
It's a negative.
Because
Marcus.
there's not a K.
Because there is not a k,
At least.
which means if it had a k, well, the k is going to be 0, right? Because the form is plus k. Thank you, Atlee. Thank you, Marcus. And that's our maximum value. Our domain, what is our domain? It doesn't really tell you what type of notation. What is our domain of this thing? All real numbers, right? What is our range of this thing?
Negative 0.
Or not 0, not 0.8.
Okay, Braden, what comes first, negative infinity or 0? Yeah, so negative infinity up to 0, and it's going to be parentheses or bracket.
Bracket. No,
Bracket.
Oh, yeah. Bracket.
Okay, thank you, Braden.
Use that.
Intervals where the function is increasing, so we'll say f of x is increasing on what intervals? So negative infinity to 0, you say, is that right, Chloe? Well, what happens is, it's sort of debatable if it's brackets. I think it's a matter of technicality. You could put a bracket here, but the book, for reasons I don't want to get it too deeply into, I prefer you use a parentheses for this, and the book also prefers that. Now you can make an argument, since the thing is increasing all the way up to 0, you can make an argument for that. But when we get into calculus, so there's a reason to make it parentheses too. So it's sort of arguable. But still, Chloe, that's good work. Okay, and where is f of x decreasing? On, I should have said on, meaning on the interval. Where is f of x decreasing? Okay, we came all the way up here. We came all the way up here to 0.8. Okay, now that's not right. Let me put it right here, because Chloe had a good idea, but she's not right. Okay, so what's that? Increasing all the way up to that. So where is the function decreasing? 0.8 to infinity. Okay, so that's it. So I want you to take a look at 6. Do number 6. Pardon me? What is your...
Number 6?
Yeah, go ahead and do number 6. We'll talk about it here.
All right.
Yeah, I think that's good.
Double spin.
Hey, wait, do not tell her that.
Okay, for this one here, 6, what is our axis of symmetry?
What you thought it said? What did it say?
From me.
You kissed me at last.
Coming from me.
On number 5, with the range being negative.
Marcus, did you tell her?
1.8.
What?
Did you tell her?
No, I see her on the story.
X equals negative 1.
Let me show you here. Chloe is referencing 5 again. Well, here's your vertex, right? So what that means is that we come right up here. Our maximum value is 0. So that's the highest point that's available to come to. So we're only coming up to if you put that in your calculator, you'll be able to see that pretty clearly, I think. Because it's right on the x-axis at 0.5, at 0.8, excuse me. So it's right here like this, and so 0 is our maximum value, which is k. So k is related to the range. So k, this value of k, in this case 0, is going right here. Okay, does that make sense? Okay, good. That's a good question. All right, now here we are back to number 6. And when you need to stop me and go back like that, that's what you're supposed to do. That's taking accountability for your learning. Okay, so x equals what? X equals negative 1. I think somebody said 1 earlier, right? But we understand it's negative 1, right? Oh.
Yeah, that was me.
Okay, well, good. Okay, and then we have the next thing. Do we have a maximum or a minimum?
Minimum.
We have a minimum,
And then one. One.
is 1. We'll call it 1. Minimum value. Our domain is going to be the same as for all polynomial functions, which is and our range is going to be what is our minimum value?
1.
So is that where our range starts? Yeah, it does. And we're going like this, right? And then f of x is increasing on what interval?
Negative 1, right?
No.
Hearing some people kind of whisper, where's f of x increasing? And where, that's a key word, where, right? Where is the function increasing? Who said -1? Somebody said -1?
Randy?
Randy.
Randy.
So -1, comma, infinity. And f of x is decreasing. Once you get that first one right, the second one should be easier. So decreasing on infinity, asta -1. Okay, so those would be that. So basically, you're looking. Did you look at that in your calculator too and graph that, kind of see what it looked like? Because that would be helpful to you too. I mean, I'm glad you did it from your mind to do that analysis, but
Mr. D,
yes.
how do you know if it's maximum or minimum?
Okay, maximum or minimum has to do with A. Okay, if A is greater than 0, then you have a what? You have a minimum.
It's positive, the rest of them, so the minimum.
Because that means, because if A is greater than 0, in this case 1/4, that means you have something that looks like this. What about if A is less than 0? I'll write up here. If A is less than 0, like in this one right here, then you have a what? Maximum. Okay? Yeah. And again, you can test it with your calculator, depending on the opportunity for you to do so. Okay? Get ready for the next class. What we're going to do next is look at changing the form of a quadratic function. Here we have we're going to convert from standard form to vertex form. And so if you have a standard form quadratic equation like this, or quadratic function, we can convert a standard form function into a vertex form, such as these here, 5 and 6 that would be a lot easier to graph. And so we're going to learn about completing the square today. And here we're given a couple examples. That here you have a perfect square trinomial. This expression on the left is equal to the vertex form on the right. So on the left you have standard form, on the right you have vertex form. This one here, this next one, x squared minus 3x plus 9 fourths, that is a standard form quadratic trinomial expression. And then we have a vertex form on the right. And so we're going to learn how to complete the square. Has anybody ever heard about completing the square before?
Yeah.
You have?
I haven't.
I've heard the saying,
Did you do that in
Miss Tubbs?
Miss Tubbs' class?
No.
Yeah, you might have heard of it,
Yeah.
but it's one thing, it is kind of more of an Algebra 2 level
Yeah.
skill generally. Now, a certain Algebra 1 levels will do that. And so here we give a form for that, but we're just going to, I don't want you really to copy that, but we're going to go through an example of that. And here they give this, I'm going to give you an easier one first than this, because that's a good one, but I want to give you an easier one. Okay, if we have a function f of x equals x squared plus 10x plus 2, we're going to rewrite this quadratic trinomial function in vertex form. Because is this function going to be easier for you to graph? Not really, from the standpoint that you don't have a vertex to work with.
Yeah.
So the vertex is going to make your life easier. So what you do for this is you create a perfect square, and I'll show you how to do it here. What you do is you rewrite this as f of x equals, and you put a parentheses here, an opening parentheses, and you put x squared plus 10x. And then we're going to have plus blank. I'm going to make a little dotted blank down here. And then we're going to have on the outside another blank that I'm going to show you why we have, and what's going to come on here at the very last, plus 2. So what we're going to do is find the number to go in here to complete a perfect square out of this deal, and I'm going to explain kind of with algebra tiles what that is in a little bit. So how do we find what this is, what goes here? Okay. Well, what happens is a perfect square. In fact, I'm going to pull out the algebra tiles card right now. Did any of you use algebra tiles in algebra 1?
Yeah. Miss
You
Tubbs
did?
brought him around a couple times.
So what you have is you have x and x, because probably the reason you did is I think it's a little bit tested on star test.
Yeah.
So that's why you saw it probably. And so the big square here would be x squared, and then these little ones here is you have 10 total, right? So that means you put 5 over here, because these rectangular ones are x's. So you put 5, so this is going to be 5x right here, okay, and then we put the other 5x right here. So here's another 5x. So what you have to do is take that middle term and split it in 2, and then completing the square is all these numbers here. So what you have is this looking thing here. You have little squares here like this to complete the square. So completing the square is the literal placement of how many little squares are required. So how many little squares are there here? There are 25. And since we added 25 over here, what do we have to do over here?
Subtract.
We have to subtract to preserve the integrity of equality, right? Because if we added 25 here, we have to subtract over here.
Yeah.
And so now we have a perfect square trinomial that we can deal with. I'm going to erase this right now.
Alright.
And I'm going to place, we're going to rewrite this as, and this is why it's a perfect square. We have x plus 5, x plus 5, and then we have what's combining like terms. What do we have over here? Negative 23. So now that's going to be quantity x plus 5 squared minus 23. And if you graph these in your calculator, I hope that you will see that these are equivalent functions. Okay, did anybody test that in their calculator? That's help. I think that's pretty cool to do. But that is completing the square, and so now can we graph this thing a lot easier? We know where the vertex is. Where's our vertex?
5, negative 23. Negative 5. Doing right.
Okay, and you'll see that when you graph that same thing up here. Because when you look at this thing up here, do you have any kind of idea that this thing is going to have a vertex down here? It's not intuitive. Okay, now if you become more and more familiar with quadratic functions, it could at some point become intuitive to you, but it's not. Are you seeing the same thing there when you graph them?
Yes.
Okay, good. All right, what I want to do is give you another one.
Alright.
And the one I'm going to give you is this. No, I'm going to do another one and show you the rule for it instead of doing the completing the square root business. How's that? Okay, so what I'm going to do is I'm going to say g of x equals x squared minus 8x plus 3. Okay, what you do, the easier way to do this is to take this middle term right here. Well, let me go ahead and write it before I do that. I'm going to write this out. X squared minus 8x plus, and then out here, and then plus 3. Okay, what you do is you take this middle term here, negative 8, and divide it into 2 parts. So if we divide that into 2 parts, what do we get?
What if it's an odd number?
I'll talk about odd numbers too. That's a good question. See, he asked about odd numbers. In fact, we'll do an example with an odd number here in a bit. But what did we get? What's negative 8 divided by 2?
4.
Negative 4. So you get negative 4, and then what you do is you square that. So negative 4 squared is 16. So that means to complete this square, you have to put 16 over here. And since we put 16 over here, we have to do what over here? Subtract 16. And so now our perfect square is going to be x minus 4 squared. And what goes out here? Minus 13. Okay? And if you see in your calculator, you will see that they are equivalent, right? Yes.
Instead of just dividing the equal to and then squaring, can you just multiply 8 by 2? And like get the absolute value of it?
Well, if I multiply by 2, I'll get negative 16.
Yeah, but then you do the absolute value of it, and then what's it the same?
The absolute value of negative 16 is 16. Well, I don't know exactly what you're trying to say, but are you trying to say that what happens is the number you're looking for is the absolute value of this? Is that what you're saying?
No, she's saying that, okay, so she's cutting down a step. Instead of having to divide it by, like halving it, why don't you just multiply it by 2 and take the absolute value of 2?
Well, if I multiply this by 2, okay, negative 8 times 2, I get negative 16.
And then if you take the absolute value of it, it's just 16.
Okay, absolute value of,
Negative 16. Just 16.
okay, I know what you're saying. I know what you're saying. I know what you're saying. What happens is, I think you're seizing upon a coincidence. Okay, let's go look at this one here. Would it be the same for this one here?
No, because it's 25.
So she's noticing a pattern. That's what good mathematicians do in the next example. But here, if you divide this by 2, the thing doesn't work here, right?
Really, let me get a key.
So, right? You see that? Okay, so some things in mathematics work out that way. It's just sort of coincidental that it happened to be that way. But it's always worth looking at those, because sometimes that's how you recognize a pattern. That's how discoveries get made, people noticing things. Okay, let's talk about, Siggy asked a question here, which was, what happens if we got an odd number? Middle term. Okay, so let's look at let's see what that looks like. Let's say, I don't want to make the numbers real big, f of x equals x squared. Give me an odd number that's not too big. 7?
7.
Okay, 7. So say minus 7x, that's not too big. And then plus, I don't know, let's do this. We'll do minus 5. Okay? The same type of thing applies. I'm going to go ahead and write this out here. f of x equals x squared minus 7x, and then plus this here. Then the outside, we're going to have plus or minus something, and then minus 5 at the very end. Okay, same thing applies. We take this negative 7 over 2, right? And we're going to, we don't get a whole number here, so we can just leave this as a fraction. So we can take this negative 7 over 2 and square it, and what do we get?
Well, let's see.
What?
12 over 4, so 3.
Okay, we get 49
Oh,
over 4. 49 fourths, okay? So this is what's going to go over here. 49 fourths.
oh. I see now.
And we have to do what over here? We have to subtract 49 fourths. And so now we're sort of getting into the minutiae of fractions. And then right here, negative 5 is equal to, that's negative 5 equals negative 20 fourths, right?
Yep.
So now we can write out the perfect square. F of x equals quantity x, and this is going to be this is what we're going to put here, minus 7 over 2 squared. and we combine these terms together, we get, what's negative 49 minus 20? Yeah, 69, right?
Yep.
And so really, what Siggy asked about is what I sort of deliberately avoided, which was doing something that I knew would bring some fractions and complexity coincident to that. But you can see that did anybody graph these and see if they got the same thing? I want somebody to do that. Haley's doing it, Lexi. At the ready.
Randy.
Now, Atlee, that was proper phone use, right?
Yeah,
Okay.
I got a text about my niece.
No, then that's not proper phone use.
About you and Ziggy's
She's
baby.
still healthy.
Ziggy's baby?
How about that?
Ziggy's
Are you seeing, get the same thing there, Lexi? Okay, so it looks good, right? But what happens is, I find that it's very helpful, okay, even for me, very experienced in mathematics, engineering, teaching, and so forth, is I've done this for years and years, yet I still get satisfaction out of checking with the calculator to see, after you do some kind of manipulation, if we have equivalency. So, I don't know if anybody gets that when they do mathematics. I think I get that. Maybe I'm weird that way. Okay, that was a good question. Let's go look at this here. Now we're going to get to the example in the book.
The book exam?
Here's the book example right here. Okay, right here, and what they do is they show a more complex example right here, right off the bat. And that's why I want to introduce some easier ones. And I want to do it my own way, so it's 2x squared plus 12x plus 10. So 2x squared plus 12x plus 10. So f of x equals 2x squared plus 12x plus 10. And what's happened is we're being introduced to another complexity here. And what is that complexity?
We have 2x squared.
The 2x squared, right? So the recommendation here is to rewrite this with a factored out form here. So we take 2 factored out of x squared, and so what goes in here? X squared, right?
X squared, yeah.
And then likewise, we take a 2 factored out of this 12x, what's going to go here? Plus 6x, right?
Right.
Yeah.
And then plus something here,
Plus 5.
and then we're going to minus here, and then we're going to put plus 10 at the very end. So we're going to have to find what goes in here to create a perfect square. And how do we find that? Or what is it going to be?
What is it?
It's going to be 9. Who said 9 over here?
Randy.
9, it's 9, yes. How do we get 9?
How do we get 9, Lexi?
You divide.
Divide by 2.
So you took 6 divided by 2, which equals 3,
Alright.
3 squared.
and then you take 3 squared, which equals 9. And so we add a 9 over here, and so what are you going to have to subtract over here?
9.
No,
Why did you divide by 2 though? Oh,
we divided by 2 to complete a perfect square.
so, yeah.
That's what we did, okay? What goes out here?
Minus.
Minus, somebody said minus 9, somebody said minus 18.
Minus 18.
Mine's 18.
Minus 18, why is it minus 18? Okay, you guys were too smart for me to fool you this morning, okay? Because really, you noticed, the perceptive ones, Bryce, and Haley, whoever else, noticed that actually this is 18, isn't it?
Yes.
So we had to subtract 18 to really accurately compensate for that. So now we have 2, we can write this as a perfect square, which is going to be x plus 3 squared, and what's negative 18 plus 10?
Negative 8.
Minus 8. So f of x is going to be that, so that's that one. So it's a level of complexity, isn't it? So you have to account for things as you go through this. And did you check that using the calculator too?
Yeah.
Okay, good. And I want to show you back to the way the book explained it here. Yeah, so they did the same thing, right? But I liked doing
You
that.
just explained it better.
Well, I just felt, to me, it just followed the simplicity. It seemed like it was more simplistic and not as academic. So that's just. Now the book has a lot of good examples and it has some rigor to it. But we're going to kind of leave it there today. Had some good questions from a lot of you, Siggy and a lot of you. So thank you for that. Mark, thank you.